Okay, so today we'll be talking about momentum in a head-on collision. So that will be two objects going at each other head-on in opposite directions. The law of conservation of momentum would say that Pi is equal to Pf. So the initial momentum before this collision, so this stage here, before, is equal to the after collision, which is what happens after the collision. For example, like that. Okay, for an example of this, we can use two cars, one at 50 kilos and another at, say, 35 kilos. The 50 kilo car is traveling at around 75 meters per second, and the second car coming right at it at 50 meters per second in the opposite direction. After the collision, it would result with both cars, both 50 kilogram car and 30 kilogram car. The 35 kilogram car drastically changing from 50 going to the left to 45 going to the right. But we're unsure of the 50 kilo car's velocity after this collision. We can find this out using the law of conservation of momentum, where this equation here should equal this equation here, giving us our mystery number. To do this, we can use the mass of the first object, times it with its initial velocity, and add that to the mass and initial velocity of the second object. Pardon me, second object. This will be equal to, again, the mass of the first object, but times by the final velocity of it, and this is in addition to the second object, the car, times by its final velocity. If we were to sub in all of our equations here, we would get 50 times by 75 plus 35 times, and now since 50 is going in the opposite direction of 50 and 75, that shall be a negative, so negative 50, and that will be equal to 50 again, because it's the same car, but since we don't know its velocity, we'll just keep velocity 1 here, and that is in addition to 35 times 45, its new velocity. If we would expand these out, we would get 3,750 plus 1,750. Sorry, again, it's a minus, so we would get minus 1,750. And we still don't know what the velocity 1 is, so we'll keep that as 50 velocity 1, and that is plus with 1,575. Completing the equation on both sides, we should get 2,000 spot on, and that is equal to, again, 50 V1 plus 1,575. Since both of these equations are the same, whatever we do to one side can be done to the other side and they'd still be equal. So if we minus 1,575 from this side, that will cancel out this. We can minus 1,575 from the other side. And that would give us 425, and that is now equal to 50 V1. Now from here, we do the same thing we did before, but with division. So we can divide this side by 50 and divide this side by 50. That would give us, so 50 and 50 cancel each other out, and that should give us V1 is equal to 8.5 meters per second. So, if we go back over here, 8.5 meters per second. So after the collision, the smaller object was to hit into the big one and go flying off at a whopping 45 meters per second in the opposite direction and slowing down dramatically the 50 kilo car. And now none of this would have happened if they just had their blinker on.